Hi students, in this video we are going to see about matrices, a very important topic for the JEE exam. So we first see what is the definition for a matrix, the types of matrices, algebra of matrices. Algebra in the sense it is nothing but the operation on matrices and equality of two matrices, symmetric and a non-symmetric and a skew symmetric matrix, which is a very important topic, and trace of a matrix is again another important topic. Transpose of a matrix and its properties, and the positive integral powers of your square matrix. Now let us see the definition for what is a matrix. Matrix is an ordered rectangular array of numbers or functions. Numbers or functions. The numbers or functions are called the elements or entries of the given matrix, and it is denoted by a capital letter. For example, we read the representation of a matrix is given by A is equal to some Aij between the brackets. Elements are given inside the bracket with an order of the element given as m by n, where m represents the row and n represents the column of a given matrix. And this I and j represents the place of the element. I and j represents the place of the row on column of the given element inside the matrix. So we will see what is a matrix. Now A is equal to, given by, the elements are given by A11, A12, A13, goes on up to the numbers are repeated for, it can take any number of columns and any number of rows, and so here up to n. So n number of columns. Next A21, A22, A23, and it goes on up to the second row, n number of columns. So we take up to here, this will be is equal to AM1, AM2, AM3, goes on up to AMN. What are all these? These element, A represents the element, and this 1 represents the first row and the first column element, I and J. The I represents the place of the row and J represents the place of the column in the given matrix. And this m by n is nothing but the order. M by n, we call it as m cross n, or given by m by n, and it is nothing but the order of a matrix is denoted by m by n. We will see another example where we take matrix A is equal to some 2, 3, 4, 5, 6, 7. How many number of rows it has? It has 3 rows, and number of columns, it has 2 columns, and therefore we say the order of the matrix is 3 by 2. Column matrix, as the name indicates, a matrix is said to be a column matrix if it has only one column, for example, and any number of rows. So we take the elements A, B, C, D. So here the order of, in this, how many rows it has? First row, second row, third row, fourth row. So it has 4 rows, column, only one column. So the order of the matrix is 4 by 1. Next, coming to this row matrix, a matrix is said to be a row matrix if it has only one row, and we give by the, represent the element by capital letter, where B is equal to 1, 2, 3, 4, 5. Row, it has only one row, and column 1, 2, 3, 4, and 5 columns. So the order of the matrix is given by 1. Matrix, a matrix is said to be a square matrix if the number of rows are equal to the number of columns, and then it is a square matrix. And the m by n matrix is said to be a square matrix if m and n both are equal. For example, I take a square matrix 2, 3, 4, and 5. Here the rows, number of rows, it has 2 rows, and column, number of columns, it has 2 columns. So the order of the matrix is given by 2 by 3. I consider another one example where B is equal to A, B, C, minus A, D, E, F, G, minus H. Now the number of rows, 3 rows, and it has 3 columns. So the order of the matrix is given by 3 by 3. So here the number of rows and columns are equal. M and N are equal. Next, coming to the diagonal matrix. What is a diagonal matrix? A square matrix is said to be a diagonal matrix if all the elements except those in the leading diagonal are 0. Aij is equal to 0 for all I is not equal to j. For example, I take a matrix A is equal to 1, 0, 0, 0, 4, 5, 0, 4, 0, 0, 0, 6. Now here in this matrix, we sub the diagonal elements, the remaining elements are all 0, and therefore here it is called as a diagonal matrix. Here when I is not equal to j, when I is not equal to j, this element is A11 element is the non-zero element, A22 element is a non-zero element, A33 is a non-zero element, I is equal to j for these elements, and for all the other elements I is not equal to j, then it is called as a diagonal matrix. And for this we have, under this diagonal matrix we have two types, that is an upper triangular matrix and lower triangular matrix. What is this upper triangular matrix? The elements above the main diagonal are non-zero. Elements above the main diagonal are non-zero. For example, 5. Then we say here it is an upper triangular matrix. The elements above the diagonal are non-zero. It is a upper triangular matrix. Lower triangular matrix, the elements below the main diagonal are non-zero. -1, 2 and 3 for example. Now here we see that the elements below the non-diagonal are non-zero, then we see it is a lower triangular matrix. Next, coming to the scalar matrix. The scalar matrix is a type of diagonal matrix, but here the elements along the main diagonal are all equal, √2, 0, 0, 0, √2. Then we say that the given matrix is a scalar matrix. So either this is called as a principal diagonal or the main diagonal. So the elements along the diagonals are all same. So here we for I not equal to j, the elements are all 0. I not equal to j, elements are 0. But I for bij is equal to k, k is a scalar, the elements are same, then we say it is a scalar matrix. Next type of matrix is identity matrix. What is this identity matrix? Identity matrix, or otherwise called as a unit matrix, where the elements along the diagonal are 1 and the rest of the elements are all 0. For example, I denote I2. I2 denotes the matrix with the order 2 by 2. Unit matrix is a square matrix. Square matrix, what is a square matrix? M and n are equal, number of rows and number of columns are equal, then it is a square matrix. Then only we go for the definition of a identity matrix. So of order 3 by 3, the identity matrix is given by 1, 0, 0, 0, 1, 0 and 0, 0, 1. This is identity matrix of order 3. Next, coming to this null matrix. Null matrix, all the elements of the given matrix are 0, either if it is of order 2 by 2 or 3 by 3, then we say the given matrix is a null matrix where the elements are all 0. Next, horizontal matrix. Horizontal matrix, n is greater than m. What is this m and n? M denotes the row and n denotes the column of the matrix. So the number of rows are less than the number of columns. 2, 3, 4, 5, 6. This is matrix A. This is of order 2 by 3. So m by n. N is greater than m. Then it is called as a horizontal matrix. It is called as a horizontal matrix. In a vertical matrix, a matrix is said to be a vertical matrix if m is greater than n. For example, A, B, C, D, E and F. Here number of rows is 3 and column is 2 and m is greater than, this is of the form m by n, m is greater than n, therefore it is called as a vertical matrices. Then equality of two matrices. Two matrices are said to be equal if the elements of the given matrix 4, 3 must be equal to the same element of the other matrix, which is equal to 2, 3, 4 and 3. Then the order of the given matrix must be the same for both the elements, and the order of the matrix are same. Then we say the two matrices are said to be equal. Each element is equal to the corresponding element of B. That is Aij is equal to Bij. Then for all I, j, the given matrices are equal. Next, coming to this algebra of matrices, properties of matrix addition. Addition is commutative. A plus B is equal to B plus A. For example, I take the matrix A is equal to 0, 4, minus 1, 2, and B matrix is equal to some 1, minus 1, 4, and 5. Then A plus B is equal to B plus A can be written as A plus B is equal to, we add the corresponding element. So this is 1, 3, minus 1 plus 4 is equal to 3, 2 plus 5 is equal to 7, A plus B, and this also will be is equal to B plus A. Matrix addition is associative. To prove the associative property, we take three matrices A, B, and C of the same order and show that A plus B plus C is equal to A plus B plus C. Then additive inverse of a matrix. Under addition, if A is a given matrix, we add a given another matrix. The sum of both the matrices is equal to the identity. 0 is the identity. Then we say that B is the inverse of A. For example, B will be the negative of A. For example, A is a matrix. Then minus of this A matrix will be the given null matrix. So we say this minus A, or here by definition this B matrix, sum of the matrices are 0, then B is the additive inverse of A. Identity under addition, 0 is the identity element, null matrix. Cancellation law, A plus B is equal to A plus C implies that B is equal to C is the left cancellation law. B plus A is equal to C plus A implies B plus implies this is equal to B plus C, and this is the right cancellation. Multiplication. Matrix multiplication is not commutative. The product of AB will not be equal to BA. Here I take the product of A and B. A is a matrix and B is another matrix. The product of two matrices, the product AB will be is equal to 1, 1, 0, 0 into the B matrix 1, 0, 0, 0. Now I multiply the first row and the first column. So the elements will be 1 into 1 is 1 plus 1 into 0 will give me 0. Next, so first row, first column is over. Now I multiply first row and the second column. 1 into 0 is 0 plus 1 into 0 is 0. Next I multiply the second row with the first column. So it gives me 0 plus 0. Second row and the second column gives me 0 plus 0, which is equal to 1, 0, 0 and 0. The product of AB. Now we multiply the product of B and A, which gives us following the same procedure, which gives us 1, 1, 0, 0. Here AB is not equal to BA, and we say that matrix multiplication is not commutative. If AB, the product of AB is equal to 0 and A is equal to 0, B is equal, or product AB is equal to 0, either A is equal to 0 or B is equal to 0. In this example, I have taken two matrices. The product of the two matrices will be is equal to 1, 1, 2, 2 into the matrix minus 1, 1, 1, minus 1, which is equal to the null matrix, which is 0, 0, 0, 0. So here, if A and B are two matrices, non-zero matrices, such that the product is 0, then either A and B are called the divisors of 0. And if A and B are two matrices such that AB is equal to BA, then we say they are said to commute. If AB is equal to minus BA, they are anti-commute. Matrix multiplication is associative. Associative property, always we take three non-zero matrices, here A, B and C, which is AB into product C will be is equal to A into the product of BC. Distributive property, under distributive property, A into B plus C will be AB plus AC, and A plus B into C will give us AC plus BC. Existence of identity, under addition we saw the identity element will be is equal to 0. Under multiplication, the identity is I. I is the unit matrix. So for any given matrix, we multiply the identity matrix, that is the unit matrix, into, or this identity matrix into the unit matrix will give us the same A element. So I is the identity matrix here. Existence of inverse. Identity matrix and identity matrix must be of the same order of A. Existence of inverse, if A is a non-singular matrix. So non-singular means determinant is not equal to 0. If the determinant is not equal to 0, then only we say there exists an inverse, which is denoted by A inverse, which is of the same order of the given matrix A. Next, we see what is transpose of a matrix and orthogonal matrix. Transpose matrix, if A is a matrix of order m by n. Transpose is denoted by A transpose, A power T or A dash. For example, I take A is equal to a matrix 2, 3, 4, 5, which is of order 2 by 2. Then its transpose, A transpose will be is equal to the first row of the matrix becomes the first column of the transpose matrix will be given as 2, 4. The second column becomes the second row of the transpose matrix. This is transpose of a given matrix. Next, coming to the properties, A plus B whole transpose will be is equal to A transpose plus B transpose. Then AB product AB transpose of the product AB whole transpose will be is equal to the transpose of the product taken in the reverse order. Product AB whole transpose is equal to the product of the transposes taken in the reverse order. A transpose whole transpose will be is equal to A, where K is a scalar, multiply a matrix by a scalar, and the transpose is taken, it will be equal to K into the A transpose. Next, coming to this orthogonal matrix. What is the orthogonal matrix? Orthogonal matrix, a square matrix is said to be orthogonal if A is said to be orthogonal if A into A transpose is equal to I, and the determinant value of the given matrix will be plus or minus 1. So if the product of, we say, the given matrix. Next, symmetric and a skew symmetric matrix. A square matrix is said to be symmetric if the A transpose is equal to A matrix. The transpose of the given matrix will be is equal to the given A matrix. Then we say the matrix is symmetric. Skew symmetric, a square matrix is said to be skew symmetric if the transpose of a matrix is equal to minus A. That is, Aij is equal to minus Aij for all possible values of I and j. This means the diagonal elements of the skew symmetric are 0. For example, we take a matrix B is equal to 0 sum E, F. Then diagonal elements we know is equal to 0. Now, the element here given as E, so the second row first element will be minus E. And next, if this element is F, this element will be minus F, and the next element, if this is G, this will be minus G, and here the diagonal elements are all 0. Then we say it is a skew symmetric matrix. And we have some points here, results here. If A is a symmetric matrix, then the minus A K scalar into a given matrix A transpose, A power n, A inverse, B A transpose are also symmetric. If A is symmetric, then all these values of the matrices are symmetric. And n belongs to natural numbers, K is a scalar, a real number, and B is a square matrix of order A. Next, if A power 2n is a skew symmetric matrix, then A power 2n plus 1 Ka and B transpose AB also is a skew symmetric matrix. And it is a very important note that a given matrix can be expressed as sum of symmetric and sum of symmetric and sum of a skew symmetric matrix. A matrix can be expressed as a sum of a symmetric matrix plus sum of a skew symmetric matrix. Trace of a matrix, a very important topic. What is this trace? Trace is a sum of all the diagonal elements of a matrix given by summation of I is equal to 1 to n aii, which is equal to a11 plus a22 plus a33, and it goes on. So here, for example, I take a matrix A is equal to a square matrix 1 4 5 minus 1 3 6 0 4. Now I am going to find the trace of A. The trace of A can be given as is equal to sum of all the diagonal elements. So it can be given as 1 minus 1 plus 4, which is equal to 4. And another important note here, trace of A into A transpose will be is equal to the trace of A transpose into A, which is equal to A11 squared plus A12 squared plus A13 squared plus sum of all the square of the elements. If it is a 3 by 3 matrix, A is a 3 by 3 matrix, A21 squared, A22 squared plus A23 squared plus A31 squared plus A32 squared plus A33 squared. Next, moving on to positive integral powers of a square matrix. For a square matrix, A power n is equal to product of A n times. So we get how many number of times? N times. A power n is equal to product of A n times. N belongs to the set of natural numbers, and A power m into A power n. These matrices are equal but the powers are different. It can be written as A whole power m plus n, and A power m whole power n can be written as A power m into n. If A and B are two square matrices of the same order, and if AB is equal to BA, then A plus B whole power n can be written as, we use the binomial expansion here. What is the binomial expansion? A plus B whole power n can be written as is equal to NC0 A power n B power 0. This B power 0 is given as 1 here. So A power n B power 0. Next element A NC1 A power n minus 1 B power 1 plus goes on up to the last term is NCn B power A power 0 B power n, where this A power 0 is given as 1 here. So this is the two matrices are square matrix, and AB is equal to BA and A plus B whole power n. We can use the binomial expansion. Next, moving on to special square matrices. A matrix is said to be a nilpotent matrix if A power m is equal to 0 and A power m minus 1 is equal to 0, and its determinant value is given by determinant of A is equal to 0. If the product of A and A square is equal to A, then we give the name as an idempotent matrix where the determinant value is equal to determinant of A square is equal to 0 or 1. If the product of A and A is equal to the identity matrix here, A square is equal to I, the unit matrix, then the matrix is said to be an involutory matrix where the determinant is equal to plus or minus 1. If A transpose is equal to A, we have seen already, this is a symmetric matrix and its determinant value, determinant of A transpose is equal to determinant of A. Skew symmetric matrix, as again we have seen already, A transpose is equal to minus A, then the matrix is said to be a skew symmetric matrix where the determinant is determinant of A transpose is equal to determinant of minus A. Orthogonal matrix A transpose is equal to I, the unit matrix, which is of the same order of A. The product is equal to product of A and A transpose is equal to I. It is called as an orthogonal matrix where the determinant value is equal to plus or minus 1. So for a orthogonal matrix and an involutory matrix, the determinant value will be plus or minus 1. Next, an important note, a square matrix which satisfies the relation A power k plus 1 is equal to A for some positive integral k is a periodic, is said to be a periodic matrix. So the period of a matrix is the least value of k for which it holds good, and the period of an idempotent matrix is 1.